Okay, this example 4, we're going to complete the square here to do this one also. And this is one where we have a leading coefficient of 2 here. So when you complete the square, you can't really complete the square when this has a leading coefficient. So what you have to do about that is you have to divide that leading coefficient off. So I'm going to divide it through the entire problems, or essentially both sides of my equation here. So this is going to give us x squared plus 7 halves x minus 11 halves, and this is still going to be 0. Okay, so you can kind of tell this. Usually, again, this method of completing the square works a lot better when you don't have a leading coefficient and this value is even. Now, let's get rid of this value and we will complete the square here. So we'll get x squared plus 7 halves x. Now remember, we're going to add some value that completes the square, which is half of this squared. We'll transpose this over, so this will be positive 11 halves. And then whatever we add right here, we're going to add to this side also. Now, recall in some previous examples here, we had nicer values. We just took this value and we halved it and squared. So half of 12 is 6, and 6 squared was 36. But obviously with a fraction here, it's definitely more challenging. Now, let's look at how we would half this number. So if I'm going to half this number, you can say you would divide it by 2 or put it over 2, which would be the same thing as multiplying by a half. So if I half this number, half of 7 halves would be 7 fourths. And there's a shortcut to halving a fraction. The way that you half a fraction is you just actually double the denominator. So now we got half of 7 halves is 7 fourths, and now we're going to take 7 fourths and we're going to square that. So when we square 7 fourths, we're going to square the numerator and the denominator. So that's going to be 49 over 16. So now we're going to add 49 over 16 here to both sides. Okay, now this makes this a perfect square trinomial. So this will factor to a quantity squared now. And you remember our shortcut here, instead of trying to look for factors, especially when they're fractions, is we just take the square roots of both of these values here. So the square root of x squared is just x. We're always just going to use whatever this sign is in my perfect square trinomial. And then the square root of this value would be 7 over 4. Square root of 49 is 7. Square root of 16 is 4. So 7 fourths. Now, over here, we have to add 11 halves and 49 sixteenths. So in that case, we need a common denominator, which would be 16. So the second one is not going to change here. And this is, like I'd said earlier, it's a good idea to maybe start using a calculator to help with the fractions at this point. Now to go from 2 to 16, I'm multiplying by 8. So I'm going to multiply that one by 8. So that's going to be 88 sixteenths there. Oh, wait a minute, we're multiplying. Yeah, that's right. Now, so 88 plus 49 is about 137 there. So now this is going to give me this very nice number of 137 over 16. Okay, now we can take, just like the other ones now, square roots on both sides. So that square root will undo the square. And since we're taking the square root on both sides, remember when I square something that it could be positive or negative to give me this value. Now, the 16 is going to work out really nice. So there again, don't really reduce this, even if you can here, because you want to keep this as a nice perfect square. And so that way, the denominator just comes out 4, just like on this one. Now, the square root of 137, however, I don't think that 137 is going to simplify. So it'll just be the square root of 137. And now all we have to do is just transpose this value over. We're going to subtract negative 7 fourths from both sides. So we get negative 7 fourths plus or minus the square root of 137 over 4. And of course, just like the example 3 here, when we get to this point, if we want to, we can write all of this over 4 as a common denominator. So here's an example there of where you have a leading coefficient that we had to get rid of. So usually I advise on completing the square unless it has, like example 1's or like example 2. If you don't have a leading coefficient and your linear term is even, it's really easy to do by completing the square. However, you can definitely tell on this one, if you have a choice, if you do not have to use completing by the square, I wouldn't advise doing completing by the square. It's much easier here probably to take this problem and to use the quadratic formula instead.